Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to use the ideal gas law to solve a couple of problems. And so we'll start with the first one. So it says calculate the volume occupied by 0.845 moles of nitrogen at a pressure of 1.37 atmospheres and a temperature of 315 Kelvin. Now, you'll notice right away that there's no change going on. We're not told that we're going from one amount to another amount, or from one pressure to a different pressure. They're just giving us a set of conditions, and they want us to find the missing part. In this case, they want to calculate the volume. So we want to find the volume, and they gave us the amount of gas, the pressure, and the temperature. So we're going to use the ideal gas law. So if you remember, the ideal gas law is PV equals nRT. So they gave us temperature, they gave us the amount of gas in moles, and they gave us the pressure in atmospheres. And so they're asking us to find the volume. We know the R value, right? So R is 0.08206 liter atmospheres over Kelvin mole. And so the first thing we need to do before we start calculating is we need to make sure that what they gave us is in these units. So we need to make sure that pressure is in atmospheres, and it is. The volume is what we're looking for. The amount of gas is in moles. They gave us moles. And the temperature is in Kelvin, and they gave us temperature in Kelvin. So we don't need to convert anything, which is good. Makes the problem easier. So that when we solve this problem, we'll end up with volume in liters. So all we need to do is solve our equation for volume. So we'll solve our equation for volume by dividing both sides by P. So pressure cancels out. So we get volume is equal to the number of moles times the R constant, ideal gas law constant, and temperature divided by the pressure. So all we need to do is just plug in our values. So moles is 0.845 moles. The R value is here, so 0.08206 liter atmospheres over mole Kelvin. And then, we need to multiply by the temperature, which is 315 Kelvin. 315 Kelvin. And then all of that divided by the pressure, which is 1.37 atmospheres. And then what you should notice is that the units will cancel out with the units here. So atmospheres is going to cancel out, Kelvin is going to cancel out, and moles is going to cancel out. So what we're left with is liters. So all we need to do is do the calculation. So we do 0.845 times 0.08206 times 315 divided by 1.37 equals, and I get 15.9432. So volume is 15.9432 liters. And then we have to figure out how many sig figs we're allowed to keep. Okay, so I look at the numbers, and my answer can only have the same number of sig figs as the least number. So this has 3, this has 3, this has 4, and this has 3. So the least number is 3. So we're going to cut it off 1, 2, 3 after the 9. So this is a 4, so that stays at 9. So my final answer is 15.9 liters of the gas. And that's how you solve the problem using the ideal gas law. Let's go to the next problem. So in the second problem here, we're given you have an 8.50 liter tire. You're told, so you're given the volume of the tire. You're told that it contains 0.552 moles of gas at a temperature of 305 Kelvin. And then they ask, what is the pressure in atmospheres and PSI? So again, this is an ideal gas law problem because they're not giving us a change in anything. There's no change in pressure, volume, temperature, anything. So they're giving us a set of conditions and they're asking for the missing piece. So here they're asking for pressure. So again, this is going to be PV equals nRT. So PV equals nRT. So they're asking us for pressure, so we'll solve for pressure. So divide both sides by volume. Okay, so volume cancels out. We get pressure is equal to the amount of moles multiplied by the ideal gas law constant multiplied by T divided by volume. Okay, so again, we need to make sure, since this is our value that we're using for the ideal gas law, we need to make sure that we have the right units. So we need liters. So we got liters for volume. Atmospheres, that's for pressure. That's what we're going to get when we solve the equation. Kelvin for temperature, we got that. And moles for the amount of gas, we got that. So we don't need to do any converting before using the equation. So good. So now all we need to do is just plug in the value. So the moles is 0.552 moles. And we're going to multiply that by our constant, 0.08206 liter atmospheres over Kelvin mole. And then we're multiplying that by the temperature, 305 Kelvin. And we're dividing that by the volume, which is 8.50 liters. So now everything cancels out. So liters are going to cancel out. Moles are going to cancel out. And Kelvin cancels out. And so we're left this time with atmospheres. So when we calculate the pressure, we're going to get it in atmospheres. So let's go ahead and calculate. So we're going to get 0.552 times 0.08206 times 305 divided by 8.50 equals, and I get 1,62536, 1,62536, 1,62536. Okay, so and then this is atmospheres. Okay, so once again, I need to check my sig figs. So my answer can only be in the least number of sig figs than what I started with. So I have 3 here, 4 there, 3 and 3. So my least number is 3. So that's where I'm going to cut it off at. Now, I'm not going to round it just yet because I have to use this number to convert to PSI, which is pounds per square inch. So if you remember, 1 atmosphere is equal to 14.7 pounds per square inch. You have to know that equality to make the conversion. So we'll take the 1.62536 atmospheres over 1, and we'll use the equality. So that is 1 atmosphere. So we'll write this down. 1 atmosphere is equal to 14.7 pounds per square inch, PSI. So 1 atmosphere goes on the bottom. 14.7 PSI goes on the top. So atmospheres cancels out, and now I have PSI. So when I do this calculation, I'm going to multiply this by 14, so times 14.7 equals, and I get 2389.28. So I get 23, so I'll put it down here, I get 23, what was that? 89.28. So 89.28. Okay, and this is PSI. Okay, so now I got to figure out my sig figs. So I already figured it out here. So this is 3. So my final answer in atmospheres is going to be, since I'm going to cut it off here, that's a 5. So this is going to be finally right over here. This is finally going to be 1.63 atmospheres. And then here, since I have my sig fig at the 2, I didn't round because I don't want to round in here. So when I'm looking at sig figs, here I have 3, and here I have 3. So my answer is in 3 sig figs. So I cut it off there. That's a 9, so I need to round that to a 9. So that's going to be 23.9 PSI. So that's the answers to these problems. So I hope this was helpful. So these are the kind of problems where you would use the ideal gas law. Again, if there's no change in anything, they just give you a set of conditions and they ask what's the missing piece, then you're going to use the ideal gas law, PV equals nRT. But you got to make sure that the units they give you are the units that are in the ideal gas law constant. So Kelvin, atmosphere, liter, and moles. If they're not in those units, then you got to convert to those units first and then plug it into the equation and then solve. I hope this is helpful. If you like this video, please go ahead and like it, share it, make a comment in the comment section, please. Subscribe to this channel and hit the notification bell so that way you can get notified of any videos I put out. Thanks for joining me, and I'll see you next time.